Okay, so welcome to my talk, Authenticating Your Users Like a Ninja, Silent Authentication in Android Apps. So before we delve into silent authentication, what is authentication? I'm sure most of you as engineers will know what authentication is, but perhaps you're new to the world of engineering or you just need a refresher. But either way, when we're talking about authentication here, we're talking about verifying a user's identity, verifying that they are who they say they are. So why does that matter? Well, obviously there's a huge long list of reasons why that might matter, but some important ones are security. If your system is not just open to the public and just anonymously usable, you want to be able to make sure that only the people that should have access to that system have access to that system. It can also just be for personalization. Maybe you've got nothing particular actually that's private, but maybe you want your users to be able to have different views or display different information at certain times or have some level of customization that needs to be tied to that user and that user identity. So that's another good use for authentication. And another, of course, is access control. Maybe you have different user groups who have different permissions, and you need to be able to authenticate that the user is who they say they are. Kind of very important things. And there's lots of ways that we can do this. There are pages and pages of ways that we can do this, but there's a couple of broad categories, one of which is knowledge-based, so things like passwords, security questions. The user is required to know a piece of information to be authenticated on your system. It can also be possession-based, so they might need to have a key card to actually access your system and physically plug something into a computer. They might need to have a phone that's registered to that system and they use that to authenticate with them. That sort of thing, you have to physically have something. It can also be inheritance-based, so you have to use a fingerprint or facial recognition or something that's unique to that person physically. So again, another way of proving that that person is who they say they are, in theory. And lots and lots and lots more. Obviously, here we're only really talking about authenticating people. You can authenticate systems if you've got systems talking to each other. There's lots of other reasons why you might authenticate, but here specifically, we're just talking about people. And then, of course, things got less secure. People realized that passwords are rubbish and can be hacked and are leaked, and people don't use unique passwords, so the same password gets used everywhere and all these sorts of things. So we came up with the idea of doing two-factor authentication. And all that really is taking two of those authentication types and smushing them together and requiring both to validate that user. So the problem with traditional authentication methods and the problem with two-factor authentication is, well, for one, password fatigue. Obviously, we've all used websites and apps and stuff that require a password. We've all gone to use our favorite super secure password only for that app to tell us, no, you need 3 special characters, your dog's name, and the last place you were born. I don't know. But the point is, they have really weird rules a lot of the time. And a lot of the time, they don't actually even make the thing more secure, really. It's just kind of arbitrary sense of security. And all it really does is lead to password fatigue, because you have to come up with a new password that you're never going to remember. You're going to have to then click that forget password next time. Or you're going to have some method to store all your passwords. You're going to have to use a password manager, which is then putting the trust in another company with all your passwords. So, is that a great idea? Or, physically write them down, which, again, please don't do that. That's possibly way worse. But on the other side of things, as a developer, when we're building systems, it causes extra friction. Any of these kind of flows, especially when you're then having to deal with two-factor authentication, we've all been there. We're trying to just log into a system, and then we now have to wait for an SMS to come in. And actually, my signal is a bit patchy where I am right now, and that SMS doesn't come in straight away. And it only lasts a minute before I have to get a new one, and it hasn't come in. And it can cause a lot of frustration. It can also cause a lot of frustration and friction when a user's trying to sign up to your system. They've found your app through an advert. They're kind of interested. They're not that bothered, but they're like, I'll download it and I'll log in. And now your app is asking them to verify their phone number, to verify their email address, to give them your mother's maiden name, or whatever else it might be, and the registration flow becomes longer and longer and longer, and people are gonna drop off. You're gonna lose users. And of course, like we kind of mentioned, a lot of these methods aren't really secure. Passwords aren't really secure. Even 2FA using SMS, it's kind of generally accepted. That's not very secure anymore. SIM cards can be cloned. People can kind of obviously steal your phone. And if you are really being targeted for an attack, it doesn't really matter that that's an extra step. They're going to be able to do that. So what's the solution to this? And judging by the title of this talk, you might start to know what that might be, but it's silent authentication. What is silent authentication? Okay, show of hands. Has anyone heard of silent authentication? We've got 1, 2, unsure. Yeah, okay, that's good. It means that the rest of the talk is going to be interesting for nearly everyone. The two of you can leave if you want. No. So what do we mean by silent authentication? Well, essentially, it's forms of authentication that don't require any explicit interaction by the user. They're things that kind of just happen in the background that the user is not aware of. And that obviously can start thinking, well, actually, that can solve a lot of the issues. If it can happen in the background and the user hasn't got to do anything, it can make a seamless user experience. In a system where you're actually really only creating users to allow them to personalize something. So security isn't the hugest issue. You just need a way of authenticating. Well, if you use a silent authentication method as your sole method of authentication, the user doesn't even really know that they're logging in or signing up. They may have a small registration process, but after that, they might not even know what's going on. So it can really give a seamless user experience. They go to the app, the site, whatever it is, and oh, I'm logged in, and there's all the things that I saved last time. It can reduce login friction through that, but also if you do actually need 2FA and you do actually need to start building a more secure system, well, use it as one of those security methods, and you've cut down the user interactions that are required to still have a secure system. Or if you really need a secure system and you're really paranoid, add it as a third factor authentication. Nothing has changed for the user's perspective. If your users are quite happy just doing 2FA and then, yeah, it's fine, it's part of life now, add it as a third factor. And now you've actually got, a more secure, that is less likely for all three methods to be compromised. It's not impossible, but the more you add, the more secure something's going to be. So there are an awful lot of different silent auth methods out there, and I really recommend you Google it and have a look and see the different options that are out there. There's lots of different kind of interesting and wonderful methods that companies are coming up with. Some things less successful than others, some things maybe not as useful, but they're there. However, the thing I'm going to talk about today, because I work for Vonage and we're sponsoring this meetup, is one of our APIs, the number verification API. Now, the number verification API is a network API. And network APIs are not APIs for interacting with the kind of IP stack and networks in that traditional sense. These are a group of APIs that have been designed to leverage the powers and technologies of 5G mobile networks. So essentially, a lot of mobile operators got together and they said, well, we have these 5G networks, which are fast, powerful. There's lots of information flowing through them. We have lots of information as well on things like who's using, what devices are using the network at any specific time, things like which cell towers they're being connected to. All this data exists. How can we expose that to developers in a useful way? And that's kind of the ethos behind network APIs in a whole. It's a very new thing. It's being worked on extensively, but a good example of an API that actually exists right now that you as a developer can use is number verification. So Essentially, number verification is its own standalone silent authentication method, API. And it does this by verifying that the phone number that the user has entered during your sign-up flow or whatever it might be is linked to the SIM card that's currently in the device that the user is using to access your system. So therefore, you know that that user has the device that they've signed up with, and it is actually that device. And it doesn't require any user input. Hence, it's the silent bit. Obviously, they have to enter their phone number as part of this registration process, but that's probably something that already exists anyway. So, in more detail, this is actually a Kamara specified API. So Kamara is a group of the mobile operators that came together and said, let's build API standards. Let's build specifications for these types of APIs. And one of them is they built a number verification standard, which our API conforms to. So you could, for example, in theory, have different suppliers of the number verification API as a developer, and you could access all of them, and you would expect the data to come back the same way. You would expect the API to work in the same way. So you could aggregate multiple providers if you needed to, much in the same way that you can for SMS. You might have multiple suppliers for sending out your SMS messages. As we dive into the technical details of it, it essentially uses kind of a three-legged OAuth process to handle the authentication, and we'll see that. So it's a little involved, but I think it's really interesting and kind of a cool new way of authenticating users. Live in production, it's currently available in Germany and Spain. As with a lot of things, as with the nature of network APIs rather, it's very carrier dependent. So carriers need to sign up and say, yes, we are now part of this. We expose our systems in this kind of the way that needs to be set up and everything else. So more and more are being onboarded, and they'll be onboarded in lots of different ways. There's aggregation going on and all sorts. Again, much like SMS was 15 years ago, for anyone that was developing then and tried to send an SMS message via an API, it was a very different landscape than it is now. Now it's very easy. Then you had to pick your operators and everything else. That's kind of where we are with this now. But crucially, we do offer a playground for our network APIs. So you can start testing and playing around with it today. You can actually demo it and use it. I'll be demoing it today, and we're not in Spain or Germany, so I'll be using the sandbox. So that already exists, so you can get started straight away. And of course, the other thing you can do is integrate other APIs as a fallback. So we have a verify API that does things like your traditional SMS 2FA. You can authenticate via WhatsApp, lots of other channels. So you could fall back to that in situations where your customer or your user doesn't have access to network APIs. So from their perspective, it can be very seamless. They wouldn't know anything's necessarily happened. They just get a text message instead of it happening automatically. So I did say it was a bit complicated. This is the kind of the flow for the API calls to make this all happen. So from our mobile app, we start at number one, we send a request to our backend. That request will include the phone number that we're trying to verify. We will then send a request to the Network Enablement API, which is essentially an API that we kind of offer as an extra thing to check if a phone number has access to network APIs. So that will look up what operator that phone number is on, what country that phone number is in, and if those two things meet network APIs. So that way, you'll get a response back, and if it's a failure, you don't have to go any further. You know network APIs aren't going to work for this user. Go do something else. If it does work, you'll get back a authorization URL instead. We pass that authorization URL back to our mobile app. This is then kind of where the magic happens. The mobile app then needs to make a GET request to that authorization URL. which will basically make a network connection through the operator's mobile network. So we force that GET request to happen over the mobile network, and we have a library that does that for you. It will then travel through the mobile operator's networks. There'll be lots of redirects, lots of that happens. And that's where kind of all the behind the scenes things are happening for the mobile operator to look up that phone number, to look up who has made that request over their network. Is that the same number that's registered to the SIM card that's made the request? And all those kind of verification is happening in the background. And then eventually, we get a redirect response. If everything's happened successfully, obviously you might get errors, but if everything's happened successfully, we get a redirect response. And again, we follow that redirect through, which will take us back to our app backend server. On the back end, part of that redirect will include a parameter with a access token, or an authentication code, sorry. So we exchange that, again with another API call, we exchange that authorization code for an access token. And then we use that access token to actually hit the number verification API at 0.5. And that's where you finally get back your response about whether or not that is the phone number that is registered to the device that's made the request. So there's lots going on there. Like I said, it's a little bit kind of multi-stepped, but obviously, first off, we're checking to see if this can happen in the first place, up to step 2. And then the rest is that kind of OAuth flow. So that's the diagram, that's that side of it. And if you're still awake, let's actually look at some code. Let's actually look at what this looks like if you're trying to implement it. So on the mobile app side, we'll have 2 methods. We'll have one method that's sending our login. So we're passing in a URL, which will be our path to our backend server, and we're passing in the phone number. So the user has entered that phone number as part of the registration flow, or maybe we've already got that back, or there's a phone number. And we're sending that to our backend server, and if we get a successful response, we'll pass the result back up with that response. On the other side, we also then have the send auth request. So this is where we're using our Vonage client library, and here we've got the, I don't know if I can highlight this. No, I can't. Oh, can I? Oh yeah, look at that. Here we've got the cellular request client, and this is basically just a wrapper for an HTTP client, which will attempt to force a HTTP request over mobile data. So as long as that device is connected to a mobile network, has a valid active mobile data connection, even if they are also connected to Wi-Fi, this request will be forced over that mobile connection, which is kind of crucially the step that's required to make this all work. They have to make the request over mobile. And then if that all comes back successful, we can check the response to see if the device phone number has been verified. If it's false or true, we can do something with it. So we put those two together, and we would send the login. We would get the result back from that. We would try and get the URL out of the result from that login result. And that would be our auth URL, which we then have to make the GET request over the mobile data. And we check if those two things have succeeded. Then on the backend side, this is Node. I do apologize. It should be Kotlin, but it's not. We have two paths that we have to make. So we have our login path, which is taking in the phone number, and we're also just going to set it as a variable stored in memory so we can use it later. And then we are going to try and hit the network enablement API here. So we're making that call, and we're getting back our response. Either we get an error back, or we're going to get this auth URL, which is what we want to send back to our mobile app. And then we have the callback side, which is where the redirect will end up hitting when we go through calling the GET request on that auth URL. So this is where we do the token exchange. So we take the token, that was the code here, which was given as a query parameter on the redirect. We take that, we pass that to our token exchange, we get the access token here, and then we finally call the number verification and pass in that phone number, the URL, and we use that access token as our authorization. And then we get the response back, which we're sending back to our app. Okay, still with me? And basically the response back from the actual number verification API should just look like this. It's just, is that device verified or not? Is that true? And true or false? Nice and easy. Okay, let's see if the demo gods are with me, and let's try and run it. So let me turn my phone on here. So I have my Android app set up here. We have our send login method. We have our send auth request method here. And then we just have a very simple composable screen. And then we have with a phone number input and a button to log in. And this is where we're doing that kind of two-step, sending the login, hitting the auth request, saying whether we're successful or we're not. And we also have our backend, which I'll just start up. So we can then, where am I? Got too many things open. So let's restart this and we'll see if it works. So there we go. Very amazing UI. I spent a long time on this. And basically, we're using the sandbox, so we're using +99 as the country code, because that then means that it's not an actual number. So we can manipulate that. So there's certain phone numbers you can enter to force a negative response, force certain errors. So you can test all the different scenarios. But this should be successful as long as it works. So we press the login button, and it gives it a second, and we get authorization successful. Well, that's cool and all, but it doesn't actually really show us a lot. So if we go into the terminal on our server side, we can see a little bit more about what's going on here. So we can see that we hit the login URL to our server. We passed in this phone number here. And so then we hit the network enablement API. This came back as a success and gave us this very long URL, which has lots of encoded things in it, if you want to look at that. So then we send that to our mobile app. We make the GET request on the mobile app side. So then our callback URL is hit back on the server, on our backend, and we're given this code and a state as well. That's just, you can record that through the whole thing. It's a unique ID, so you can check the flow for a specific call. We've got the code, so now we can make a call to the token exchange. We get an access token back with information about the access token, when it expires and everything else. So we can make a call to a number verification API. We get a successful response back. And it says device number verified equals true. So there you go. That is the demo. And it worked, which is nice. So that's everything on that front. If you would like to check this out, please do feel free to scan the QR code and set up an account. Yes. Yeah, sure. Set up an account. You do also get 10 euros free credit if you are interested. And obviously, feel free to look at our other APIs and stuff. But you can get started with the sandbox straight away. And I will just say thank you very much. We'll do questions in a second. Thank you very much. If you'd like to get the slides for this or anything, they're available on my GitHub. And also, that QR code sends you to all my social media links and all that sort of fun stuff. Thank you.